Myself K. Sirisha, working as assistant professor in mechanical department in MVR College of Engineering and Technology. I would like to teach the subject of thermodynamics to second semester, second year, first semester. Um, Coming to the topic thermodynamics equilibrium. In thermodynamics equilibrium, we have three types of equilibrium states. Those are thermal equilibrium, mechanical equilibrium, chemical equilibrium. What is thermal equilibrium? The temperature of the system does not change with time and has the same value at all the points of the system. For example, we will take a glass of water. Its temperature is considered as 25 degrees centigrade. After 1 hour, we will check the temperature with the help of thermometer. It gives the same temperature as the before, is 25 degrees centigrade. Then later 2 hours, it will give the same value. So that means change with the time, but the temperature of the system remains constant. That is, we consider as thermal equilibrium. Second one is mechanical equilibrium. In mechanical equilibrium, there are no unbalanced forces within the system or between the surroundings. The pressure in the system is same at all the points and does not change with respect to time. Same, uh, we consider one block. I will apply one. Uh, I will force on one side, and the other person apply the same amount of force. Then the body will be in equilibrium position. That means the body is balanced force. When I remove them, one force on one side, it is unbalanced. That means our system will be our system will be compulsory in balanced force. So when the system is balanced, that is in mechanical equilibrium. Chemical equilibrium. What is chemical equilibrium? No chemical reaction takes place in the system. So no chemical reaction takes place in the system and the chemical composition. So which is same throughout the system, does not vary with the time. For example, if we consider water, what is a water? What is a water chemical composition? That is H2O. After some time, it is H2O, and then after 1 hour, it is H2O. So the chemical reaction does not change. That means chemical reaction is in equilibrium position. So that is known as chemical equilibrium. So the above following are the three types of equilibrium state must be assured as thermodynamics equilibrium. Next state, path and process. What is state, what is path, and what is process? So before going to this, I will go here first of all. So what is state? This is a piston cylinder. So initially the piston is here. The piston the piston in this position. So what does it mean? Here in this position, the properties of the system is P1, B1. So when I applied some amount of force, that means the piston is compressed. So the piston is compressed, it slowly changes its states here to here. Here the system of properties are changed. P2, P2. This is P2 and P2. So the properties are considered here. By depending upon the properties, we mention the state. So that is state 1. So here also the depend upon the properties, we mention the state 2. So this is called as a state. Okay. So what is path? Here state 1 to state 2. In between we are having infinite number of states. So we are connecting each and every state. 1 to state x1, state x2, state x. So in between the number of states, between 1 to 2 is known as a series of states. So we are connecting the series of states. So finally connected 1 to 2. So by connecting series of states, that is known as a path. And next coming to the process. What is process? The change of state. So initially state is 1. So I are applying some compression energy, compression force. It is changes its state 2. So the state 1 changes to state 2 is known as process. So go here. So what is state? What is a condition of system? Condition of system, as defined by properties of system, is known as state of system. So this is a state. Series of state. This is the series of state. Series of state through which the process. So 1 to 2 is a process. Series of states through which the process occurs is known as path of the system. Any change of a system, say state 1, it will be changed to state 2. So any change of a system is known as process. So some of the processes are there. Isobaric process and isobaric process is nothing but constant pressure. Isothermal process is nothing but constant temperature. Isochoric process is nothing but constant volume. Isentropic is nothing but entropy. Those are all the process. And next, path point function. So what is point function? When two coordinates are located on the graph, they define a point and the two properties of the graph define state. This properties P, T, B are called point function. So I will show you. So here, so what is coordinate? So here are the y-axis, here the x-axis. In x-axis we consider volume and y-axis we consider pressure. So how you will make a point here be depending upon the coordinates. In the x-axis volume. So initially state 1 property v1 and property p1. So we consider like a point. So depending upon the coordinates on the graph, we consider it as a point. So that we can call as a point, that we can call as a point function. Then next point, path function. So path function is nothing but there are certain quantities like heat and work cannot be located on the graph by a point, but they are represented by the area. It is not a state or point function, rather it depends on the path of the process. Such quantities are called path and they are exact differentials. Here we can show the points only, point 1 and point 2. We does not show how much amount of work and how much amount of heat. So how we consider heat and work by depending upon these areas under the curve 1 to 2, 2 to 3 process. Here under the curve we can show the how much amount of work and how much amount of heat. But if we actually for process 1 to 2 and 2 to 1, so we are taking another process 2 to 1. So this area and